Welcome to the grade 10 periodic trends tutorial. Right, think of an atom as a sphere whose radius is determined by the electrons that are furthest away from the nucleus. All right, and because of this nature, this allows us to come up with a trend or generalize when it comes to the atomic size of each element, whether down the group or across a period. All right, so if I draw a simple Bohr model structure, so let's say this is the nucleus, all right, the nucleus of an atom, and there you've got some protons and you also have some neutrons. Right, so around the nucleus, right, there are orbits, all right, or there are energy levels in which is the place where the electrons are sitting. So we have the first energy level, and the energy levels keep increasing and increasing. All right, so in this case, so the atom or the element whose outermost electrons are sitting on the first, let us say, energy level or period, all right, is going to be smaller than an atom whose electrons are sitting on the second level, all right, second level. And the atom who has electrons sitting on that second level, right, is going to be smaller than the atom whose electrons or furthermost electrons, or what we call valence electrons, are sitting on the third level. All right. So if we check maybe in a nutshell, which means if we are going down the group, right, so we will have, for example, maybe first level, and then for the second level we'll have 2 rings, and then we have maybe 3 rings for the third level. So if you check the size of an atom as we move down the group is increasing. Okay, so we can therefore say size across, right, or I mean down the group from top to bottom, size is increasing. Okay, size increases. Right, what about across a period? Right, or across a specific level, right? So when we say across a period, we're talking about across a specific energy level. All right, so as we go across a period in the periodic table, right, the energy level stays the same, right? So which means if we are looking at first or rather second energy level, right? So the outermost electrons are all sitting on the second level. So this would be n equals to 2, right? That means this is period 2, right? So what then happens is as we move across, there is an increase in the nuclear charge. There is an increase in the number of protons that are there in an element. And because of this, it creates increased attraction, all right, electrostatic attraction between the nucleus and the outermost electrons, right? As a result, then these 2 energy levels, right, this period will therefore now begin to shrink, right, because those electrons will be pulled a bit more closer, all right, more closer to the nucleus. So this is what we start seeing. We start seeing them decreasing. So because of this, as we move to the right across a specific period or energy level, therefore the size of an atom decreases. All right. So if you check here, you will see this is a graph, right, showing the trends of atomic radii or the atomic size as we move across a period. So these lines that are drawn, all right, this is across a period. This is across, right, across a period. Across a period. All right, so you can see from lithium all the way to fluorine, in general, the trend shows a decrease in size. Lithium and fluorine are all in the same period. And there you can see again from sodium all the way to chlorine. Sodium and chlorine are all in the same period. You can see that there is a general decrease in the atomic size. And that's because of what I just explained earlier, because of increasing positive charge. All right, but if you check lithium, sodium, and potassium, and rubidium, and cesium, they are all in one group. If we look down the group, you can see that lithium, right? Lithium is at the top of group 1, whereas cesium is right at the bottom of group 1. But you can see if I draw a line there that there is a general increase in atomic size from top to bottom in a group. All right, so let's look at what the general trend is. So the general trend here is that as you are in a group, size increases down the group, and also atomic size will decrease with some exception as you move across a period. So now let's look at some application of this. All right, so we're going to look at some of the elements and see if we can look at the periodic table and arrange them properly. So we're going to try and arrange each of the lists, okay, according to increasing atomic size. So let's look at aluminium, sulfur, phosphorus, chlorine, and silicon. All right, so let's go, and first we're going to go and circle them right in their periodic table. All right, so let's begin to circle them out. Okay, I'm going to use the black color. All right, so we have aluminium. All right, we have aluminium, and then we had silicon, we had phosphorus, we had sulfur, we had chlorine. All right, so you can clearly see they are all in the same period, and we know that as we move across a period, size decreases. So the question says arrange, okay, according to increasing size. So according to which means from smallest to biggest. And we know that the elements on the left, therefore, will have what? A bigger size. So which means in our arrangement, we are going to start with chlorine. So which means chlorine is smaller than sulfur, which is smaller than phosphorus, which is smaller than silicon, and which is smaller than aluminium. Okay, so that's how to arrange this. All right, so we have another list there. So we need to first go on the periodic table and circle them. Okay, so I'm going to delete the first ones. So let's circle these new ones. Okay, so we'll start there with indium. Okay, there we go. We circle that one, and you can see there is the Ga, and then there is aluminium also. Right, so also we have a B. Okay, so if we go up here, there it is. All right, and then I have, right, there we go. So I was not given them in order, but when I circle them on the periodic table, right, or maybe you can use a highlighter, it's easy to now see the trend. We know that according to the periodic trends of atomic size, right, as we move down the group due to increasing energy levels, right? So if you remember when I drew it for you, right, so you will have increasing, right, you therefore have increasing atomic size. So, which means already this is in order of, so we'll start with B, or obviously, and then we move to B is less than, okay, there we go, and then, okay, so basically that is how you arrange it. So I did one that was in the period and one that was in the group. So that's how it is done. Now let's look at the atomic sizes of ions. Right, when ions, all right, have the same charge, usually that's in a group, okay, that's in a group. You can see I'm underlining that there. All right, so size will decrease as you move up the group, right? So the trend is going to be similar to that of neutral atoms. All right, what if you're moving down the group? Same thing, right? If you're moving down the group, right, size is going to increase. Right, that is in a group. All right, now let's look at the size of parent, all right, parent to the ions. Right, first we'll be looking at the size of parent to cations. All right, so the parent in terms of cations, all right, the parent is always bigger than the cation, and the reason for this is that the bigger the charge, all right, the bigger the positive charge, the stronger the attraction. Okay, so it's still the same, for example, still the same element, all right, but if we check ion 2 plus and ion 3 plus, all right, the ion 2 plus, all right, if its energy level or its period, all right, or maybe if this was the size, just assume that this was the size, right? If this was the size, then the ion 3 plus, okay, the ion 3 plus is going to have an even smaller size, okay? Right, it's going to have, the size is going to shrink, and this size is shrinking, right? It's shrinking because there is a bigger positive charge. Bigger positive charge, remember, even as we move across a period, bigger positive charge means stronger attraction between the nucleus and the electron cloud. So because the electron cloud will therefore get smaller with increasing charge. Okay, so I can say increasing positive charge leads to smaller electron cloud. So it leads to smaller electron cloud, right? And obviously the electron cloud determines the volume of the atom, all right? Which therefore leads to a smaller atomic radii. So it leads to smaller electron cloud due to, all right, increased positive charge, okay? Right, and due to increased attraction. Due to increased attraction between So this is between the cloud, and nucleus. All right, so this is what is happening. Now let's look at maybe this size of parent to n ions. Right, since the n ion, all right, the parent n ion, right, if the parent n ion was, let's say this was the size, okay, let's say this was the size of fluorine. All right, so when you add an electron to the fluorine, there's going to be a repulsion between the electrons, so they're going to try and get further away from each other. So what's going to happen is fluorine minus, right, is going to have a bigger radius, right? So when it comes to the n ions, the parent is going to be smaller, whereas the ion is going to be bigger. Okay, and that's because you are increasing electrons. When you increase the positive charge, the size becomes smaller, but when you increase the negative charge, the size becomes bigger. Okay. Now let's see if we can tell which one is smaller, which one is bigger. Right, let's answer these questions. Chlorine and chlorine minus. So you can pause the video and answer them yourselves, and then afterwards see what answers we have given. All right, chlorine or chlorine minus, which one is smaller? Okay, so with the n ions, we know if you increase the number of electrons, you increase the size. Therefore, all right, the smaller one is the parent, all right, is the chlorine there. Between the sodium and the sodium plus, right, which one is the smaller one? All right, we look for which one has a bigger positive, right? So sodium plus, bigger positive, therefore smaller atomic size. This one have the same charge, oxygen with a 2 minus and sulfur with a 2 minus. So how do we decide that? We did say that if it's down the group, then it follows the normal trend, right, as the neutral ones. So as we move down the group, right, with more energy levels, that means the sulfur is bigger, therefore the smaller one is going to be oxygen 2 minus. All right, and then magnesium plus and aluminium 3 plus. Okay, this one is easy. Bigger positive, all right, means being smaller because there's going to be a stronger electrostatic force of attraction between the nucleus and the electron cloud. So gold also is going to be the smaller one. All right, what about across a period? Okay, so if you check, the more positive, right, the smaller, okay. The more negative, right, the bigger, okay. So if we check this, right, if we arrange this one, right, we can see that more negative, which is nitrogen, is bigger, bit less negative, which is oxygen, followed by 1 minus, then plus, right? So in this case, size is decreasing as we move from most negative to most positive, all right? So there is a decreasing size.